what I've got in here is 1 molar sodium sulfate, some universal indicator, 20 milliliters of water. Okay. We've used universal indicator before. Universal indicator actually is going to contain 3 different indicators. It has phenolphthalein, it has methyl red, and I believe bromophenol blue, which is why we get all 3 of these ranges from this. Okay, so what I'm going to do is pretty simple. I've got an electrolysis apparatus here. This is just going to have 2 electrodes, which are just metal screws, and wires, which I'm going to try really hard to keep out of the solution. Okay, 2 tiny baby test tubes that I'm going to fill completely with solution and then put on my electrodes. Okay. And then hopefully, start again. Turn this upright without getting these turned over. Okay. So, now that I've got this, we're going to connect it to a 9-volt battery, and then I'll rearrange this so you can see it a little bit more. Okay, so things to watch for are obviously formation of a gas, as well as change in color. Yeah, so hopefully, there we go. Sodium sulfate, okay, water, and a universal indicator. So we're just going to let this go for a second. Okay, the universal indicator obviously is there to provide the change in color. The sodium sulfate is acting as what? This is obviously an electrochemical cell. Sodium sulfate acts as the salt bridge, yeah. Okay. So if I can get this in my picture here, it's probably going to be a little backwards. Our universal indicator, okay, I would say we're probably a 4-ish or a 5-ish range there, and maybe like, I don't know, 9, that purpley color. Okay, I'm going to let this go just a little bit more. So this is the electrolysis of water. My 2 gases are hydrogen and oxygen. Okay. 2 gases are going to be hydrogen and oxygen. Okay. So I'm going to let this go just a little bit more because we're going to prove that these are hydrogen and oxygen in just a second. And that should hopefully be enough.